All right, so we're going to talk about soil amendments today. So our learning objectives today, we hope by the time you leave, you'll be able to identify potential routes of contamination associated with soil amendments, explain soil amendment handling practices that may reduce your risks, identify key strategies such as composting or other interventions that you might use, application intervals to help reduce risk. Also describe corrective actions that you can use if a soil amendment does present a risk after you've applied it on your field. And then identify record-keeping tools for monitoring and managing your soil amendment, handling, application, and use.
And as you may be able to discern that there's a logo down here at the bottom that says the Produce Safety Alliance. So this module is actually a part of their day-long workshop. So this first presentation's part of a standardized curriculum which has been developed to help people actually adhere to the produce safety rule. Honestly, many of our growers in Tennessee are not at the size or scale where they have to be compliant, but it just kind of gives you the basics of what's required for compliance. And again, it's all based upon sound scientific principles, so that helps frame everything. It's good practices in general. So what is a soil amendment? It sounds like you all have a pretty good handle on that based upon the fact you're already using them in your operations. But soil amendments are truly any chemical, biological, or physical materials intentionally added to the soil to improve and support plant growth and development overall. So a lot of times I think people just think about, when we talk soil amendments, they're just thinking about things like manure or hopefully composted manure. And they don't really truly think about the other compounds that you could be adding into improve soil health. Again, some of the benefits may reduce soil erosion and sediment runoff, and the many types of soil amendments are available, truly showing the breadth and depth. And we heard some of those fish emulsions, things along those lines. Again, some soil amendments can produce a produce safety risk. Many of the ones we're going to talk about in this class today are actually tied to biological hazards. So if you have a foodborne pathogen, and a pathogen is just a fancy word for a bacterial microorganism that can make you sick. Present in manure, and it survives composting. If you're applying manure directly, then there can be a risk there. But there's still other risks that can be tied to chemical hazards and things along those lines that we'll mention. Assessing risk and implementing good agricultural practices, which is what GAP stands for, are ultimately, hopefully, what you'll take away from our presentations today.
All right. So, am I a soil amendment? Fish emulsion. Holly already answered this one for us. Yes, it is a soil amendment. Compost tea. Another one. Inorganic fertilizer. Yep, it is.
Yeah,
it's a chemical. It's a
Yep.
chemical soil amendment. Not one that we often think about because we think about more of the biological soil amendments, but definitely, and we're going to talk about some of the potential risks associated with those chemical things. John covered the chicken litter. This is pelleted poultry litter.
So biological soil amendments, especially those that include untreated or what we always call raw manure, pose significant microbiological risks. So again, they can carry those foodborne pathogens with them. There are many animals that will naturally be infected with some microorganisms that can make people sick when passed on to foods. Some of the ones that are more prevalent include things like Salmonella and E. coli. There's many groups of E. coli. The ones that we're specifically interested in a lot of times get abbreviated to STEC, which stands for a specific type of E. coli, which if it infects people, makes them have kidney failure and many times strokes is kind of the worst case outcomes. But again, they're just a small group of those overall E. coli groups. And there are many different types of both wildlife as well as domesticated animals that would be totally symptom-free and have these microorganisms in their GI tracts and excrete them into their manure. Again, though, chemical soil amendments can also impact food safety. Again, you always have a label which dictates application rates and maximum use levels and days prior to harvest for which chemicals can be applied. And risk should always be assessed when selecting and applying any soil amendments onto produce fields.
So assessing your risks. You all mentioned the soil amendments you're using on your farm. So,
I have a question.
sure,
Yeah.
go ahead.
Just that previous slide, produce fields, how do you define that?
So we would define any area where you're currently growing. The question was, how do you define produce fields? So the answer would be any area where you're actually actively growing crops
We're
or
growing-
intend to grow crops
We're
in
growing
the future.
fruits and vegetables.
Yeah, fruits and
So it
vegetables.
would apply really to grazing.
No, unless you rotate that into your fruit and vegetable production.
Yeah.
Yep, it's where you're doing your fruits and vegetables that we're concerned with.
Yeah.
Yep. Yep. So what type of soil amendments do you use? Are you using raw manures? It didn't sound like anyone's using raw products except maybe John using some chicken litter stuff. And then composted manure. Well, we'll talk about that. Yeah, yours could still be considered raw if it's been sitting in your barn for 20 years. It's just an old pile of horse manure. It's not really compost. So yeah, that's a great question. And we'll talk about that a little more. So composted manure, chemicals, or other amendments. And then what crops receive those soil amendments? So is it your fresh produce, or is it your agronomic crops, or is it pasture? And then you rotate those into your fruit and vegetable rotation. And when do you apply them? So the days to harvest before you're going to harvest that fruit or vegetable crop, and the time of year you're going to apply it. Are you applying it now, or are you applying it in the spring right before you're planting? How do you apply them? Do you incorporate them into the soil? Are they laid on top of the surface, or are they injected down into the soil? And then how much and how often do you apply? So we know that excessive application, more is not always better. Excessive application can lead to environmental impact, so we want to minimize that as well.
So when it comes to our chemical soil amendments, typically they do pose minimal microbiological risks. So they are very rarely will those compounds ever contain microorganisms. I would say one thing to be cognizant of, many people mix their chemicals and may have holdovers they'll use for multiple weeks if they don't utilize it all. We have seen instances where if those chemicals are left in holding tanks, then they actually can grow microorganisms because there's plenty of nutrients there for them to feed on, basically. So always be cognizant of the fact that while the compound itself in a concentrated form doesn't really have those microorganisms, you can introduce them through the water that you're using and through your holding practices. And again, we're talking here with synthetic fertilizers and minerals along those lines. Again, always make sure the personnel that are using are in charge of your fertilizer program, if they're using synthetic chemicals, make sure they know how to properly apply and use those chemicals that they're using. And they also are trained on what their own personal protective equipment or PPE needs to be able to apply those and follow those specifically. Always follow those application instructions. As we always like to say, the label's the law, and don't have any off-use label usages is most important. And then always have proper labeling and storage practices in place so you don't have any chemical risks that come about due to leaking or anything along those lines. And again, people are going to be trained in this through pesticide training that in order to be an applicator for their farm.
So when Faith was talking about the microbial risks, mostly we'd see this when you mix up a batch of fertilizer that you're putting in with your water that you're going to water things in with as you plant. And if that sits in the tank for a while, it's going to get nice and warm in the sun, and that's when we're going to see issues. So just be aware of that if you're not using it all at once, that you don't have it sitting around for a long time where it could be have the potential to produce microbes. Yes, Tom?
Do you put pesticides in that list too?
Pesticides?
If you're applying them with your soil amendment, we would. I mean, they're not a soil amendment per se. They're doing their pesticide activity, but oftentimes we do apply them
Together.
in the planting water, sure. So that would go in there too. And going back to that, it depends on what your water source is that you're using to water those plants in. So if you're using a surface water source, you have a much greater chance that you're going to have microbes in there to begin with than if you're using well water or municipal water as your source of that planting water. So you want to be cognizant of all of that. Human waste and biosolids. We're glad to hear nobody's using humanure on their farm because human waste is prohibited for use on produce crops unless it meets the EPA regulation for biosolids. Untreated human waste, as you may know, can contain pathogens and does contain pathogens. It can also contain heavy metals and other contaminants. And more in Human waste, we see drugs that go through the system and are still active in that human waste. And they may not be accepted by your produce buyers. So, since you're not using them, don't start.
So vegetative waste, many times we focus so much on manure and composting of raw manure that people kind of lose sight of the fact that you can have the vegetative material that's incorporated into that compost or being applied to the field as part of a hazard. So vegetative waste can contain chemical hazards, and we'll talk about one here in just a moment on the next slide that is especially troublesome, not from a food safety perspective necessarily, but from a production standpoint. Definitely shows how these chemicals many times will be resilient and actually survive that process very well over time. Physical hazards, so things like glass, metal, think about those sorts of hazards coming into that waste stream. And biological hazards also. This is not an animal only. Many times these pathogens are found in our environment in general, and therefore vegetative waste can also survive on, vegetative waste very easily. So again, any sort of food waste streams definitely fall into this category where you have any sort of green material going in. Out-of-date vegetables, many people will put their culls into their compost bins and things along those lines, and food products removed from, again, their packaging already, as far as a waste stream goes, if you may be receiving those from some areas.
So as Faith mentioned, one of the risks that we're seeing, which is not necessarily a food safety risk, but is definitely one that we want to talk about, is herbicide damage from manure and straw that you might be using on your farm. And we see more and more cases of this every year. So it is important to really know where your manure is coming from if you are composting manure, or even if you're buying in compost, you want to know all the details of that compost. If it has manure in it, where were they getting that manure? What were the pastures treated with that those animals grazed on? Because this is a big deal. If you're applying compost, even compost that has been properly composted, these chemicals, and they're in the class of aminopyrrolid or picloram herbicides. Grazon is one generic name that's fairly well known, but there's a lot of different names, and it's these aminopyrrolids or clopyrrolids that we're talking about. They're still active even when they go through that animal system and even when they go through the composting process. So I've had people call and say, I applied this compost to my entire farm and now my plants are dying. What do I do? How long is it going to last? And the answer is we don't really know. There's no weed specialist that I've found that will give you a time limit of how long those will be active in the soil, because it depends on your conditions at your farm. It's going to depend on the temperature. It's going to depend on how much rain leaches through that field in a given time. And so the answer that we usually get is 2 to 4 years. That's a long time to put your farm out. Tomatoes are particularly sensitive to this. Grapes are another one that's very sensitive. Dr. Neil Rhodes in Plant Sciences Department has done some work with preventing off-target herbicide problems in the tomato field, and he has some good diagnostics to know which herbicide you're dealing with there, and he addresses this one as well. And this is also a problem in straw. So even if you haven't applied compost to your field, but you get straw bales from somebody that used this on their straw, you lay that down. If you're growing tomatoes, those tomatoes are going to curl up and you're not going to get a good crop out of them. So you really want to be careful where you're getting your straw and know everything that might have been applied to it as well.
Is there a way to test manure to find out if this is in it? If you don't know?
Well, that's kind of, you can. It's very, very expensive to do. So that's a good point, because I almost forgot my little demonstration here. What we do with our compost now, when we get a pile of compost, because we don't want to fool around with our organic certification either, because this could knock you out if you apply it on your field, and that's an herbicide that you're applying unintentionally, but it's still an herbicide. So what we do is we do a little assay with bean seeds, because beans are very sensitive as well. And these we planted a week ago, and they're not as far as long as I had hoped, but this is one with 100% compost in it, and those beans are coming up all right. But what we're really curious about is once the leaves come up, if they're going to have the disfigured appearance, and with a lot of herbicides you get a leathery appearance because that's how they work. they change up the photosynthesis and you get really thick leaves. And so that's what we want to see. And if you get a pile of compost, I would highly recommend that you do some assaying of it to make sure that it's not going to put your crop back. Because if you're running a CSA, even if you're not an organic grower and you're running a CSA and you have a deadline, you're planning on your bean crop being ready for those first boxes in May, this can set you back a good long time. So you want to know what you're dealing with. And this bean assay is great. Just put a few bean seeds in a cup. We did 100% compost, 50% compost, and 100% soil, just as a comparison. Curiously enough, our 100% soil didn't even germinate yet because we have really heavy clay soil, and you can feel them if you come up and feel them later. It's very heavy compared to these other two. So normally we use compost probably at a rate of 1 part compost, 3 parts soil. So however you would normally apply it, you definitely want to make sure that that's not going to harm your bean plants. And that's really easy to do. Just have a pack of bean seeds around so you're confident that when you're putting that compost on, you're not jeopardizing your certification if you're organic, and you know it's not going to stunt your plants.
And beans are the most sensitive thing. They'll germinate fairly quickly.
Beans are one that's sensitive. Tomatoes are sensitive, but they would take longer. So beans are really easy to see. Once those first true leaves start coming out, you can tell pretty quick whether you're seeing any herbicide effect or not. So
Is this Grazon? What's the common name? Grazon?
Grazon.
Grazon. Yeah.
Yep. That's one common name, but there are a lot of common names for it. That's just one of the most common names. So you really want to know if you have aminopyralids or clopyralid herbicides that were used on the field. And some people might not know what you're talking about when you use the active ingredient versus a common name, but you need to be sure if you're putting it on your fields for sure.
Great. So again, there's even other types of non-manure-based soil amendments we have. So things that fall into this category are bone meal, fish emulsion, feather meal, and blood meal. So again, they should be processed in a way by the person manufacturing those to eliminate possible foodborne pathogens that may be there, or they must be considered untreated biological amendments of animal origin. And many times, whomever is supplying those to you will actually be able to give you either a certificate of analysis or a letter of guarantee, which is kind of a blanket statement that says that we've processed these in such a manner so that they should not contain harmful foodborne pathogens, and actually list, like as I said before, typically we're looking for Salmonella, Shiga toxigenic E. coli, and maybe even Campylobacter would go into that category for especially things related to poultry. The certificate of analysis is specific to the lot that is being manufactured. So that would be they would send that product out for testing at a lab, and they would give you the results back in a letter that would accompany that shipment. That tends to have an extra cost that comes with it, so many people will rely upon that letter of guarantee to kind of be a blanket statement to cover everything you're receiving from that supplier.
And generally that process that they're going to use is going to be a heat treatment.
Yeah, that's right. It's a heat treatment, and just making sure. And honestly, by actually just getting these amendments in the form that they're in, they have to go through a heat treatment to get them in that state.
So pathogens in animal manure. And Faith is more of the expert on this. I'm going to let her cover this one. She loves pathogens.
So ultimately, you should look at any raw manure as a potential source of a foodborne pathogen. Is it 100%? No, but it is a fairly good percentage of manures. As I said, completely healthy looking animals will many times be carrying these pathogens. Again, many animals, and unfortunately most of our livestock, from cattle to pigs from swine to poultry, all can be reservoirs for these foodborne pathogens. And honestly, when it comes to the animal state, there's many things that can affect their shedding. The age of the animal, the rearing practices of the producer. Many times if an animal's stressed, they're more likely to shed. Similar to age, many times if they're very young, they're more likely to shed these pathogens as they get older. Diet, a lot of attention's been paid to grass-fed versus pasture-raised cattle specifically. And what I'll say is that the literature is not clear on if there is a difference in shedding as far as that diet goes. Initially what had happened is a study came out, kind of one of the Sentinel studies showed that there was a difference, and people haven't been able to replicate that. So probably there was a confounding factor that they weren't controlling for in that study that actually led to those results. So as far as that diet goes, it doesn't necessarily play out, but in essence, are they on pasture at all? Are they primarily confined? Things along those lines do play a role. Season, we do tend to see these things spike in summer and kind of go down in winter months. And other environmental conditions can definitely also play a role. Many times it's not only shedding, but it's actually that organism surviving very well in the environment once it gets out and is somewhat stressed in the normal environment.
So that's a lot to consider if you're applying manure or even if you're composting.
That's why we just always think that it contains a pathogen.
Right, yeah. Because you probably don't want to go through all those things with something that's providing you the manure. Okay, how old were these animals and what season is it? And that's still no guarantee to know how much of a pathogen may be there. So
Why do you see a spike in the summer?
So it tends to be that it's more prevalent in the environment. So if they're drinking water and it happens to be contaminated with a certain pathogen, then they're more likely to harbor it in their GI tract. And these organisms are a lot like us. They like our body temperature. So you get closer to that temperature during the summer months, whereas the winter, especially around here when you have freezing temperatures, they're definitely not growing. And if they are in the environment, and many times they're just kind of laying low and just hanging out, not actually actively increasing in numbers. Yeah.
So the FDA term is untreated biological soil amendments of animal origin. But the common term for that, generally what we're speaking of, we talked about the blood meal and the feather meal and the bone meal, but basically we're talking about manure. So when you see that untreated biological soil amendments of animal origin, that's basically what we're talking about. It's manure, good old manure. And it is going to be considered high risk for all those reasons we just saw in the previous slide if it hasn't been treated to reduce or eliminate those pathogens that are shed naturally by the animals. And Faith has mentioned Salmonella and E. coli 0157H7.
That's like our most prevalent type of Shiga toxigenic E. coli. So that's the group that we see most commonly in the United States.
And that one's really important because all it takes is 10 cells to do a lot of damage. So when we're talking about bacteria, it doesn't take, usually you're starting out with more than 10 cells and they're doubling every 20 minutes. So they build up very quickly.
So untreated manure, again, we're talking about raw manure, but to the example of using, hey, I have this barn, it hasn't been cleaned out in a while. Many people have that situation where they have aged or stacked manure sitting in a location. And again, you should also view that just as untreated manure. It's just an old pile of untreated manure versus a fresh pile of untreated manure. Again, slurries, watering it down doesn't do anything. You know, a lot of people say, well, if I added it, you know, it's not in its raw form. I've done something to it. But you haven't done anything that would actually inactivate those microorganisms. And again, teas also fall within that category, definitely.
How about manure teas?
Yeah,
Yep,
so
that's still on
yeah,
there.
manure teas definitely fall into, if it's not coming from compost, then it's a raw manure still.
And I think we'll talk about that more later, but
Yeah.
if you start to add things to that, especially like molasses, then you can add a whole heap of trouble. You're feeding not only the good bacteria that might be in there, but also if there are any foodborne pathogens in there. So you want to be aware of that as well. So reducing soil amendment risks. Things you can do to reduce risk, of course, the first one is selection. Not use raw manure to begin with is one good way. And then treating it. So if you're doing a composting process and really doing that properly and getting things up to temperature, that can take care of it. And then application timing. Generally, we want to have a longer period between applying and putting our crops in the field and harvesting as we can. And we'll talk about that a little bit more too. And then your application method. If you're just surface applying, that's going to be more risky than if you're tilling it in or injecting it or something like that. And then handling and storage and your record keeping. So we'll delve into all of these in more detail.
Great. So composting as a treatment in general is our approach for, making, honestly, the nutrients that are in that material more readily available to the crops that you're growing. But in addition, you get heating of that material during that breakdown, and that's going to fuel actually an activation of any pathogens that may happen to be there. So that's really the method we're using to try and inactivate these risks. Again, we're going to walk through the steps in a composting process, and you're going to be able to surmise that it can be fairly labor intensive, especially if you're talking about not having equipment on hand and things along those lines. So to try and get so that you're essentially cooking every portion of that compost pile, because what will happen is inevitably you're going to reach a certain temperature within the pile, but what's along the outside's not going to get to temperature most likely, and so you'll have to have turning basically to make sure that you're covering everything in an open pile. We'll talk through the scientifically valid processes that have been validated to inactivate microorganisms, what temperatures you need to reach, and how long those temperatures need to be maintained. And again, as with anything, if you're doing something for a food safety purpose, it's really important to write down those practices and have the records to back up. And we have in our second presentation some actual examples of records. A lot of times we sit up here in these workshops and tell people to keep records, but if you've never done it before, it's sometimes hard to know. So we'll cover that at the very end.
And also on your USB that you have log sheets that have the records already, and they're in Word format, so you can take them home and adapt them to your farm. You don't have to start from scratch. And that's where a lot of people think, oh, I'm looking at this blank piece of paper. What do I need to be keeping track of? And so that lays it out there. If you do things a little differently and you want another column or something on there, it's easy enough to add, but you're not starting from scratch, so it's easy to do. So your composting options, as Faith mentioned, you must use a scientifically valid process. And these two that are listed here are those that the FDA has currently recognized as scientifically valid, but they are open to other scientifically valid processes. If there's something you do differently and can back it up with science, they're willing to entertain that. But it's a process to get that approved. So these are already approved processes. The first one is using aerated static composting. And this is generally on a larger scale that we see this. So it's an aerobic process. That means getting that air in there. And you need to reach a minimum temperature of 131 degrees Celsius, or Fahrenheit, 55 Celsius, for 3 days. So it's fairly quick if you have this aerated system. Not a lot of people do this, though. This is larger scale. And then you want to follow it by curing with proper management to ensure that those elevated temperatures are throughout all of the material. The second one, which we see more often, is turning your composting. So that can be with a machine, either a windrow turner if you can afford one, or you can use, a front end loader that you might have on the farm or something such as that. Or you can do it by hand, which we've done plenty. But you're going to turn that compost, and it also has to reach that minimum temperature of 131 degrees Fahrenheit. But this time it's for 15 days, and you have to do a minimum of 5 turnings within that 15 days, and then you have to follow that by curing as well. And an important thing when you're doing composting is also to make sure you have enough moisture in that pile. You want to think of it like a wrung out sponge. You don't want it sopping wet, but you don't want it dry, because that all helps in the process. So that's what I always tell people is think of a wrung out sponge.
When it comes to reducing risks during application, again, Annette's already mentioned a lot of these things. So if you're using raw manure, apply those to crops that are not commonly consumed raw. So by doing that, if a pathogen happens to be in that raw manure, people are going to actually apply a cooking step within their own home. So it's highly unlikely that those pathogens are going to make it through that cooking step if it's properly done. So examples there would be things like corn, squash. People always amaze me with what they're willing to eat raw, but potatoes, those sorts of things. So keep that in mind if you want to use raw manure applications. Again, maximize that amount of time, and we have some recommendations based upon the National Organic Program recommendations for time intervals between application and harvest that we'll walk through during this session, but try and ultimately maximize that time from when you're applying raw manure to actually harvesting that crop. Again, you're going to see a decline in those pathogens if they do happen to be present over that time interval. Again, try and use raw manure definitely on crops that aren't going to actually touch the ground. So things like tomato plants, things that are up off the ground, so that you don't actually get that soil contact.
Sweet corn's a really good one because it's up off the ground and you generally cook it. So
Yeah, it's a double win.
Yep.
Don't side dress with raw manure, and we know a lot of people, have reported to us when we've been doing workshops that practice if they're using raw manure. And again, minimize risks to adjacent produce crops if you're field spreading manure. A lot of times people are like, well, my crops are growing over here, and I'm spreading raw manure, way over here. It's not actually on the crops themselves. But these microorganisms are really small, and I guarantee you, when you're spreading manure, that's being cast into the wind, even if it's not a windy day, and you're going to see drift by quite a good distance. They can fly like 600 feet or more, and it doesn't take a whole lot because they are so small. They just get on dust particles that you're generating.
And is that field that you're putting it on uphill from your produce field, so it could run down as well. So you want to be aware of all of those issues too. And just as we've already mentioned, just like we can't tell you with the herbicide when that herbicide will be out of a compost pile, there's not a lot of good evidence for raw manure when those microbes will be out of that pile. That's why getting it up to that temperature and getting it through that composting process is so important, because there's no scientific evidence that says, okay, if you have this pile of manure for 20 years in your barn, there's no active microorganisms in it. So that's why it's really important to have this process, or to take all these things in mind and not apply them right before you're going to harvest a crop.
What we've seen when they have done holding studies is that typically the microorganisms will be at a fairly high level in the raw manure when it's applied, and they tend to decline fairly rapidly. But in essence, they reach like a steady state where they don't continue to get down to not being present at all. And while for the average healthy, person, that's not going to make them sick if it happens to get on a crop, for the people that are more commonly impacted, which I always call them yoppies, but young, old, pregnant, and immunocompromised, which in reality are a large portion of the people you're selling to, as Annette said, it can take as few as 10 microorganisms being there. So even that very low level can be a risk to you.
So minimum application intervals. There are currently no application intervals for raw manure that are outlined in the Food Safety Modernization Act Produce Safety Rule, which is what all this curriculum has been created for. However, when they had some of the first drafts come out of that Produce Safety Rule, they had a 270-day minimum application period between application and harvest for your crops. That's 9 months. That's a very long time. Okay, it did come back. So the other thing about applying the manure is, just like with the herbicides, it's going to depend on your environment, and it's going to depend on how hot it is. That's why you will not find a good recommendation that says, okay, if you've applied manure this far in advance, it's safe, because it's going to depend on if you're in Arizona and have a lot of sun, or if you're up in Seattle where you're not going to have as much sun, and all of those things come into play there as well too, because UV is great for getting rid of a lot of these microorganisms, but you never know how much you're going to have, and there's no good recipe for that. So that's what I was thinking of before. So for untreated soil amendments, the FDA, this is one that they have on reserve. So they are looking for further research in this area to actually put numbers to when you can apply these raw amendments. But in the meantime, they're not going to counter the National Organic Program. And we'll talk about that. I think it's on its own slide. The raw manure must not be directly applied to harvestable portion of the crop. So Faith has already covered that. And then for treated soil amendments, there's a 0-day application interval. So if you have a compost, you can apply it today, harvest this afternoon if you want. And there's no time interval in between that, as long as it went through that scientifically validated process.
So speaking to the National Organic Program standards, which are truly the only standards that benchmarks out there for application of raw manure, if the raw manure is actually going to touch the edible portion of the crop, you have to wait 120 days between application and harvest. So that's a 120 days interval. If it's not going to touch the edible portion of the crop, then it would be 90-day interval from application to actual harvest. So those are the best standards that are currently out there. Again, the data is really mixed because there are so many factors at play here when it comes to using raw manure.
So
Yep.
could you put it on now? But you're not gonna go to the crop store
Right.
in February or April.
Right.
You could do that.
You could. You're going to lose some of the impact of putting it on now, but yes, you can. And a lot of people do that. If they have it and they need to disperse it on the farm, sure. Yeah.
Not just something, but you'd add organic matter, probably. Not just something new.
Right. Right. Exactly.
Would this apply to flowers?
Flowers? Are they edible flowers? Then no.
So for ornamental purposes?
No. Nope. They're good. All right, so handling recommendations. You want to designate specific tools and equipment for handling your soil amendments. So you might put certain color tape around the label or something and know that that's just tools that you're using for handling those soil amendments. You want to develop SOPs or standard operating procedures to clean and sanitize your equipment and tools that contact your soil amendments and fresh produce. And in every workshop we do, we talk about these SOPs because they're important, and I think they're another thing that people think, ooh, how do I write an SOP? We have examples of those from the food safety decision trees that are on your USB, and that was a project that we did with Cornell and the University of Minnesota. And it gives you food safety language, it gives you the SOPs, it gives you records and logs, and a nice little decision tree to assess your risk on your farm for each of these components that we're talking about. So there's one for soil amendments. And an SOP is nothing more than how you would do something. And when we say that, you really want to think about how you do it, and you want to write those steps out, and then you want to hand that SOP to a worker, if you're not going to be the one doing it, and make sure they do it the way that you think they would. And the way I always like to explain it is making a cup of coffee. We all know how we like our coffee, or if we don't like coffee at all, but can I make John a cup of coffee? Does he take 1 lump of sugar or 2? Does he take creamer? So write out all those steps, because we will all make a cup of coffee differently, and it's the same thing. For SOPs, we often think this is common sense, sanitizing a tool. We have a good video from the University of Florida where the guy tells one of the workers, triple wash this lettuce. Well, he does it in a very different way than the person that was telling him to do it probably imagined. And so you really want to make sure that somebody's going to do it the way that you would exactly want them to do it, and that's where those SOPs come in handy. If you hand it to somebody and they don't do it the way you were thinking, add some more steps in there till they're doing it the way you want them to do. Then direct traffic, both foot and equipment, around your soil amendment storage or processing areas. You want to direct it around so you're reducing the risk of cross-contamination. Oftentimes people like to put their compost pile right outside of their packing house because it's easy to just throw the culls out there. But you want to be thinking about that, and you actually want to give it good distance for several reasons. You don't want to have people tramping through there, because that could provide some cross-contamination. Oftentimes those piles attract wildlife, so you don't want to attract that right around your packing house. So there's a lot of reasons to have it further away, and this is one of them, so you're not going to get that cross-contamination in there.
Yep, and on that note, ultimately we want to kind of locate our piles in such a way that they do not pose a contamination risk, as Annette was saying, to our fields or our packing areas, but also to the environment. Again, you know, if these nutrients are all going into waterways, you can have essentially too many nutrients present and kind of fouling there. So by creating things like berms, which will allow for essentially that runoff, or trying to actually locate them in an area where you're not going to get runoff, especially into waterways, and leaching of those nutrients is really important to consider. One easy way we always like to think of is definitely for compost and manure. As Annette was saying, you're going to be attracting wildlife, and so it's nice to keep them covered so that hopefully you're minimizing that risk. And also, a lot of people will use simple tarps and things along those lines with basically things to weight them down to try and deter animals and rodents from getting in there. Again, Don't store in areas that are likely going to have runoff or close to those water sources, because we don't want, definitely if it's untreated manure, but also anything that's very nutrient rich going into those waterways and leaching in there. Again, if you have piles of both raw manure and compost on your farm, keep those separate. And I think that, that goes to reason, but a lot of times people are like, no, this is the area we do that in, so they keep everything in one area, and ultimately they end up cross-contaminating each other, especially when you get things like rain events and wind drift and things along those lines. And always, as Annette was saying, try and minimize animal access onto those areas, because you're going to have the whole gamut from insects to larger creatures being attracted to them.
And if you do have piles that are in fairly close proximity, you want to think about what Faith said, that these are going to be airborne if there's pathogens there. So you're not going to really reduce that. But again, if you're placing your piles, you want to think about a new pile is going to go, this is Tennessee, we know we don't have a lot of flat ground. So you want to be aware of where that new pile is going, so it's not going to run down into a finished pile. Worker training. So any worker that's going to be handling your soil amendments, both treated and untreated, should understand those SOPs that we talked about for properly completing their tasks, which require managing raw manure or compost. You want to think about clothes and boots and gloves. You want to make sure they're clean before handling produce. The easy way to do that is to have a pair of boots that you wear when you go out and do the soil amendments, if you're the one that does that, and then another pair that you put on when you're done, if you're walking through the packing house or somewhere else on the farm, so you're not trailing that into the packing house. And then, of course, you want to wash hands after handling all of these things. We always want to wash our hands when we do everything.
Record keeping is the bad word nobody likes, right? But honestly, record keeping, you're already doing many of the right things, but documenting that is going to be essential for, especially if you hope to get gap audited. And we mention gap auditing a lot. Essentially, gap auditing is where an individual comes in, a third party, will come in and actually check the practices you have in place on your farm, as opposed to a standard that has been developed by either a group, like the USDA has good agricultural practice schemes, and they're just checking your practices against what's recommended. So definitely, if you're going to go through an exercise like that, which to get into many markets is becoming increasingly important, you're going to want to have documentation, because that auditor can tell what you're doing the day that they're there, but they don't know what you're doing the other 364 days out of the year. So record keeping's key. The things we want to think about with record keeping are the type and the source of soil amendments that you're applying, the rates of application, and also the date that soil amendments are applied, handling and sanitation practices that you may be using to reduce those microbiological risks. And then there are a few records that we're actually going to be required for treated biological soil amendments of animal origin within the produce safety rules. And so we'll cover those in our next slides.
So with the produce safety rule, you'll notice the difference between this up here where it says you should and then required. There's a lot of that in there. So should are things that are not specifically required. There's shoulds and musts a lot throughout these slides as well. And you want to make that distinction, but even though it's a should, it's a best practice. And Faith mentioned going through a gap audit. Even if you're not going through a gap audit, first of all, if you're keeping these records and something does happen, it's one more thing that you have. If you have to go back and say, well, we did this composting process, it's just smart business for you, even if you're not going to go through that gap process. The second thing is if you start doing these records, it's going to be painless if you decide that you do want to have a gap audit. And then you go and you're all ready for that. And if you do get a gap audit, oftentimes it opens up markets for you that you might not have considered before. So that's always a good thing. And we see this a lot with farm to school. A lot of schools want you to have a gap audit to get into the school, which is smart when we're talking about one of those immunocompromised populations, the young, the kids. If you're selling fresh strawberries to a school, and heaven forbid there's an outbreak, it's going to be immediately apparent. So if you've gone through that gap audit, all the better. Hospitals, same thing. So it can open up your markets. So record keeping for on-farm composting, the key factors in that process must be documented. So we went through the times and temperatures for both the static pile and the aerated pile. And so you want to keep the time that that pile was up to temperature when you started that pile, and then the temperature. So you're going to take that temperature and make sure that either that 3-day window you were above that 131, or within that 15-day period you maintain that 131 degree temperature throughout. Then if you're doing the turning for that aerated pile, you want to make sure that you've documented you've done at least those 5 turnings. And this is important not only from the food safety perspective. I always say that it's not just things you're doing for food safety, it's a double win-win because it's for production as well. If you're not getting that pile up to temperature, you're going to have plant pathogens in that pile, and you're going to have weed seeds that aren't going to get killed in that pile. And we all know we don't need any more weeds on our farms, so we want to make sure we're getting up to temperature and killing those weeds. And then other processing steps that might be in there.
Can you do this any time of year, or are there certain times of year that are better?
Composting? No, you can compost any time of year. With the composting process, it's still going to get up to temperature whether it's the winter or the summer if it's done properly.
Great. So whenever we have standards in place, and it's a little hard to talk about that because we actually don't have minimum time intervals now between application of raw manure and when the crop can be harvested. But once they are established, and definitely if you're in organic production, you're following that 120 and 90-day rule, we need to have corrective actions that we can go through in the instance where we don't meet that minimum time interval. Or if we have unintended applications, such as I didn't intend, the edible portion of the crop to come in contact with this raw manure, but lo and behold, something happened, and it did.
My worker didn't get the memo and applied it to the lettuce crop.
Right. Something along those lines. So again, you're just going to be outlining those steps of what you're going to do to actually try and address the issue. And many times, it's simply that. Your first step is trying to do an assessment of what your true risk is. And then inevitably, in not harvesting that crop until you've made that assessment. So that's going to be step 1 in all corrective action plans. Inevitably, if you do believe that there is a risk, Nathan likes to say this a lot of times, your first loss is your best loss. And I think that's really hard to put that into perspective when it's your livelihood, right? But if you truly believe there could be a risk to consumers, then it's better just to destroy that crop. You could, however, for some crops, there's an alternate path that you could take, such as if I was growing tomatoes and they were intended for fresh market, and I could find a processed market for them where they would go into like salsas or some other where they're going to receive a processing step to inactivate those pathogens if they happen to be present. Then for a few crops we can find those alternate with a food processing step to mitigate any risks that may be there.
So that's like heating?
Heating would be one of the big steps that we apply. Unfortunately for fresh produce, they're just not prevalent, that doesn't require a thermal process. If certain processing steps that are non-thermal or a little bit more widely adapted, some people will use processes like high pressure processing as a non-thermal process that some of our processors will use and can use fresh produce in that you may not think about otherwise. So a lot of our dips and things along those lines may be still fresh but not process. Again, a lot of our frozen commodities and things along those lines will go through a blanching step, which would be another way of inactivating those pathogens if they happen to be there. But again, that's a cooking step. So things like lettuce, you may just be out of luck.
Trouble.
Yeah.
And we're seeing more and more community kitchens pop up, so that's a good place if you do need to process something to find your closest community kitchen. And oftentimes, if you're processing, sometimes you can be getting more money than if you were selling a fresh product. So it's making lemons into lemonade.
For sure.
Heat-treated lemonade, that is.
Whenever you have a deviation from what's required, you need to document this. So you need to actually document what occurred, what you did to assess that risk, and ultimately what your final end game was. Things you're going to capture other than what the actual actions were is actually how much product was put at risk, and essentially document everything from beginning to end for that record-keeping step.
All right, so the summary, this is between you and lunch. Soil amendments can introduce produce safety risks. I think we've made that case throughout this past hour, especially those that are going to contain raw manure. To reduce those risks with soil amendments, we want to make sure that we're applying untreated manure to non-produce fields, treating that raw manure using a scientifically validated control process, or extending that time between application of raw manure and the harvest of your crop. And then make sure your storage areas do not contaminate your fields. So we're going to minimize that contamination, or your water sources or your packing areas. Train your workers who handle those soil amendments on how to handle and apply them. And then we want to develop sanitation steps for your tools and equipment, and you want to keep records of your soil amendment application and treatments.